And I think it's time to start. It's 4:44, so I think the guy should be ready already. So can I see the next speakers? I know that there should have been 4 of them, but only 2 will be joining us. Oh, you are so young. I am so old. No way. No way, guys. I missed my train. Now I understand. I should have programmed since 14. You started first and now, oh, I'm never going to be able to catch up. Hello. Hi. These guys are Falk-Moritz Schaefer. Hi. Jan Trebschuh. Hello. André Motz. Hi. And Sagar Veeranna Shiva. Is that correct?
Yeah, it's correct.
Sagar Veeranna Shiva?
Yeah, it's correct.
Okay, wonderful, wonderful. I would love to be able to read it with the correct Indian accents, but I think you have like 20 Indian accents in there, so I don't know which one to choose, so I'll skip with the English pronunciation. Guys, you look so young, and you made robots who can navigate the space without connecting to cloud. I've been hearing about this for 5 years now. Let's wait for 5G because that's going to be fast and the car will be able finally to communicate really fast and pass the information. And you tell me you don't need that? Falk, is that correct? Now you tell me they made the 5G, they put the networks on so the robots can communicate in gigabytes, and you just tell me, no, we don't need the robots to communicate. That's okay. They can just come back and upload everything to the cloud, and they can walk for 2 hours, avoid obstacles, walk the minefields, and they don't need. Is that correct?
That's what we call the intelligent edge. So they can also entirely work offline. And yeah, we'll explain a little bit how that works. But obviously 5G is also good to have, right? So
it's always good to have. But if you have this edge, you have to have it on the robot. You have to do all the computing on the robot, right?
Not on the robot, but at the edge between the cloud and the robot. So
okay. So you just, I think I heard some people, some of my friends are working with some famous German brands. They do car testing and they bring this like huge container by helicopter. They put it there and they crunch the data over there, so they don't have to say send 20 terabytes. They only say 20 gigs of the. So do you do something like this?
Yeah, it's related, right? So the massive amount of data, if you put it all to the cloud, you always have the problem of connectivity or moving terabytes of data, right? With the hard disk to the data center. And doing it at the edges is always a good option in terms of cost, yeah, but also in terms of latencies. And yeah, it's now part of the cloud computing continuum that we can use and use as a solution designer, right? So it gives us a lot of freedom.
Okay, and one question from a guy who knows shit about the technology you work on. What is AGV? Is automated ground vehicle?
Automated guided vehicle.
Guided vehicle. Yeah. I was like, if it doesn't fly, so it doesn't fly. We want to tell you it's just ground. So.
Okay. It's on the ground, yeah. So it's a land-based robot, yeah, not an air drone, but it's also guided in terms of there is some predefined path it always takes, yeah. And now we see the evolution to mobile robots, so autonomous mobile robots. That's the next stage of the AGV.
Wow, I think this is what is going. Your technology is going to be walking on the Mars. I think you have the age to be able to do this, and I think you will take a Falcon 9 and there will be your robot flying to another planet because this is the technology we are going to need there. Okay, I'm not going to steal from your time. Guys, enjoy your talk, and I'm looking forward to hearing about this. So Robots and AI by Falk-Moritz Schaefer, Jan Trebschuh, André Motz, and Sagar Veeranna Shiva. There you go, guys.
Thanks a lot. So I will share simply my screen and I hope you can see it.
Yes, we can.
So you will understand more what this is all about because we'll explain a little bit about the technology architecture and also show you a demo that makes it much more tangible. But first to ourselves. So I'm Falk, a part of Accenture Technology based out of Germany. And I'm leading a team of software engineers focusing on IT, OT engineering, as well as I'm part of our technology innovation practice where we look at robotics. And with me, André, Jan, and Sagar. Maybe a quick intro from your side as well, André.
Yeah, maybe just a sentence or hi and nice and thanks for the warm welcome. That was really nice. I'm located here in Garching in Munich, Germany, and I'm part of we call it Liquid Studio within Accenture, which is focusing on rapid prototyping as well as minimum viable product developing. We are not just focusing on IoT, but of course we are full stack developers, extended reality developers, AI, and so on, you name it. And I'm the IoT tribe lead. But with me, I have Jan as well. Jan, maybe you can also say something.
Yeah, hello everyone. So my name is Jan. I'm sitting here right now in Düsseldorf. I'm also part of the IT/OT team with Falk, and within our showcase was my role as a lead software engineer, and I will tell you a little bit more of our architecture and what components we have used to implement these showcase for you. Over to you, Sagar.
Oh, thank you, Jan. And hello, everyone. I am Sagar. I'm part of IT/OT team led by Falk. So today I'm going to give a short introduction about the user interface and drive the demo. Thank you. Over to you, Falk.
Very good. So I will speak a little bit about what we call the intelligent edge at Accenture and why we are dealing with robotics, and then show you a little bit how we put this two areas together into a reference architecture. And then I will hand over to Jan and Sagar for the fun part to show you the demo and the showcase. And then Jan will speak a little bit more about what tools and tool stack we've used for that demo. And in the end, we have some time for question and answers. So let me first introduce a little bit what we mean by intelligent edge. So edge computing has been around for a couple of years, at least the concept. But some companies understood, yeah, that's just what we've been doing all along, with all offline solutions, and that is something we call now edge. And other companies looked at it, yeah, that is the communication network. That's what we call edge computing. But the truth is, a combination of that and still a little bit different. So if you look at IoT, the traditional IoT was a device, right? And then the central cloud platform. And now with edge computing, we have something in between the device and the central cloud platform. And we now see that technologies developed originally for the distributed systems in the cloud are used now at the edge and even at the device tier. And that opens up a complete new solution area for designers and architects, because we can now very flexibly decide where logic functionality is hosted. We can put it onto the device, we can put it at the edge, or we can put it on the central cloud. And we can flexibly adapt this decision even during runtime and move logic back to the edge or back to the central cloud. And that is, very much a game changer in that area, because I remember a lot of discussions also with factory people who have been saying, yeah, this fancy IoT solution, I can use it, but then if connectivity is down, it doesn't work anymore. I cannot allow that in business critical functions such as production environments. And now with the intelligent edge, there's literally no reason anymore not to use cloud technologies also for such sensitive areas, because we can put it at the edge. It runs even if internet connectivity is down, and then still use cloud technologies and the central cloud for what it's good for. So there's a little bit the intelligent edge. And now we combine that with the topics of robotics. So Accenture's Tech Vision a year ago had the trend that was called robots in the wild. And that is exactly describing what we see now in the area of robotics. Robots are moving out of their industrial cages. They are coming out of core manufacturing logistics and are now used in other industries in very different use case settings. So coming out of predictable environments robots are now used in very unpredictable environments. Think about the Amazon solution, Scout, that goes around and delivers goods to end customers, can autonomously navigate even around humans on the sidewalk, or look at Walmart, who are adopting robots to clean the floor, to do inventory stocking, or look at agriculture, where we see robots now being used to automatically do seeding and harvesting at a field, right? So this is where we see a lot of traction in the robotic space in the next years, and Accenture is active in that area. Obviously, we don't build robots, hardware, but we have a lot of partners who do, and we build around the software and do the integration around that. So this is where our clients ask us where and how to adopt robots, how to connect them to the overall enterprise system landscape, how to make them more intelligent, more ready for the human-robot teaming, how to optimize fleets of robots. So this is where we as Accenture get active. And we now looked at one area that is especially interesting in the next years, and that is around inspection. So mobile robots used to inspect halls, floors, factories, and so used for data acquisition as a first step. And there we developed a reference architecture, and that's usually happening when looking at capabilities. Yeah, so top down, what are capabilities, an end-to-end solution used for mobile robots for inspection, what capabilities are needed. And obviously on the lower side, you can see some infrastructure components. It's a robot itself with all its sensors, actuators. We have the connectivity infrastructure. And then we have technical capabilities around security, device identification, authentication, data processing, logic, getting access to the data, doing the data management that's coming from the robots, and also then processing and logic execution. Think about workflow execution, complex event processing, exception management, and so forth. And then the human interface, human machine interfaces, equipping the robot also with conversational capabilities, doing notification management. And then we have functional capabilities such as the map management, the warehouse management, the fleet management, energy monitoring, and so forth. And then we have our intelligent edge reference model. So this is a little bit showing what I described before. On the left-hand side, we have the edge device. In our case, that's the robot. On the right-hand side, we have the central cloud. And in between, that is what we call the intelligent edge. It can be a simple gateway that is hosting some logic and data pre-processing. It can be a more complex infrastructure, such as a set of virtual machines at the factory level, or even a hyper-converged infrastructure. And then we have the telco communication network, which in the future will also provide not only communication services, but also compute services to their customers. And now I can exploit this whole continuum to put logic and data processing where it makes sense, where it's cost effective, and where it allows to do it in time processing. So in the top, I have then a platform layer that allows me to orchestrate this complex distributed system, with allowing me to deploy new services, put them to the edge or to the central cloud. And I have an infrastructure layer which constantly monitors the execution and can adapt to that. So maybe I have a communication outage or a shortage of compute resources at some way, at some stage or the other, and then I need the platform layer to act on this infrastructure information to adapt flexibly to the context. So that is a little bit the intelligent edge reference. And now putting it together, and we come to questions, okay, which capability do I need to put where? And there are certain questions to answer. So one example is around how much compute resources are required for this capability, for this functionality. Think about machine learning. Usually we would do the training of machine learning models, which require a lot of data, a lot of compute resources in a central cloud. But then the execution of a machine learning model is happening at the edge, right? So the inference, the execution is happening at the edge. Another question to answer is how time critical are certain things? So think about real-time movement, physical interactions, this processing of this logic that decides if a robot stops or goes forward, usually you want to have at the edge. Whereas then questions around data longevity, I've seen many setups where they build databases locally, and after a couple of months or years, they just explode because they don't want to waste or throw away data, but keep them long-time storage. This is something usually you do at the cloud, right? And then also the availability question comes in mind. Things do you depend on? Yeah, you usually don't want to put to the central cloud where you have communication problems. Maybe that is something you would put at the edge. And then one other aspect, except for data regulation and sensitivity of data, is also the question of cost, right? So central cloud also, costs money, right? So the cloud provider want you to pay its services, and there now with the edge, you have much more flexibility also to optimize systems, and this optimization is needed to make things not only feasible in a technology sense, also to make use cases viable. So now I will give over to the showcase where we put a lot of different technologies of that area together. Our intention was really to get a first-hand experience with open source tools and cloud tools in that space, and do it in a do-it-yourself style. So we took a mobile robot, we put a ROS on top of it, we used an edge device from AWS and the central cloud services, also AWS, and made it work for our showcase. And that's quite a very interesting area of technologies to put together and get a hands-on experience with. Still evolving space of technologies, both in terms of open source, in terms of cloud services. There's a rapid movement in that space, and was good to know how to put it all together. And very proud about the showcase we have assembled. So handing over to you, André.
Thanks, Falk. I think that totally makes sense that we all know now what this is all about. But I think nothing is better explaining something if you don't really have a showcase, right? So if you maybe can hop to the next one. Maybe just a few thoughts on the showcase we will just demonstrate you in a second. Yeah. So this is about an intelligent edge for autonomous mobile robots showcase, right? Because we want to demonstrate like the intelligent edge and several technologies that are in there. So we are focusing on an automated inspection. So we had this idea in mind. Hey, let's take some internal money, like internally funded money within Accenture, and use this and build like a nuclear waste disposal automated inspection demo, right? So where robots drive around, and we in Germany, we have this problem of the atomic waste disposal question, and we want to have robots maybe that drive around. So have this in mind what this is about. Yes, just a funny use case, but you get the idea. So robots will perform an inspection with the camera and detect anomalies, and they are logged and then displayed to the operator. And also what is interesting is that the whole surrounding will be used during the inspection for further learning. Yeah. As said already, we want to focus on the intelligent edge capabilities. So you see that the generated data that we actually produce there is being processed on the edge, not in the cloud, because it totally makes sense to do this on the edge, right? On the other side here, we are Garching with 5G connectivity, so that we also can demonstrate some low latency internet connectivity, which is of course interesting, for example, when it comes to streaming, right? And of course, on the other side, right, you can think of further use cases or application areas, different sites, plants, big halls, and, especially all areas where it's dangerous for humans or it's like very expensive to get there, you can always use robots, right? And, of course, there are different industries we could think about. So we think about the retail business, insurance companies, or just like the, I think, top industries that are interested in such technology. And we also see like an increase or forecast for the next 5 years. And it is also expected that like this kind of inspection and surveillance will cover like around 11% of the overall robotics and drones spending up to the next 4 years. But let's talk a little bit more about our use case. If you can go to the next slide. We have we would like to showcase 2 use cases. One is the line above that you see there, which is like, imagine you as the plant manager maybe want to define an inspection on the site and schedule it, right? So then the robot operator can start it and trigger it and inspect like what is there around on the floor and in our nuclear disposal area. Then the robot performs the inspection, and that is run by the operator. finally a video is being processed, and via AI magic, we do the processing and detect some anomalies, if everything is fine there or not. And then finally, the plant manager gets a list of incidents, maybe, or relevant images or footage that is worth to archive. The second use case is what we integrated or implemented as well as like a complete fleet control, so that the robots automatically like take up a task and like decide which individual robot will drive around. And then finally, the robot performs the predefined inspection, right? So this is all what AGVs or AMRs, so we call them, are all about. If you can go to the next one. And then you see, like, if we now, what Falk just described in theory, how we implemented it in our showcase. Yeah, this is very high level, the architecture. But if you look to the middle, there you see this edge device. You will see it in a second. This is from AWS. It's called a snow cone, which is basically a computer where you can run AWS services on it, on premise. Yeah, so on the edge, this is our edge device. And if you see to the left, we have the robots connected to that one. We do the robots control via the edge device, the video streaming and the recording goes straight to the edge device. Of course, the edge device provides a local database and is doing the computer vision processing via YOLO 5, I think it was. And then we have the cloud, which is we are using also to update the machine learning models on for the devices, right? We have all our software based on the cloud and AWS dashboards. And this plant manager then can use our dashboard to do the inspection results and control. And finally, you see above, there we have our user interface where we can control the robots, check the archive, what was ongoing there, see the live video stream, and yeah, decide if there's something worth to mention. And that's basically our showcase. If you think now, if you go to the next one, then I think let us switch to the demo. And therefore, I switch my camera. And maybe you can stop, share your screen. And I think you all see my camera, right? And here is my nice colleague, Sagar. Hi, Sagar. He will speak also in a second. You see here, this is our demo area in Garching. You see our robots. Let me just zoom in there a little bit. This is how it looks like. So they look nice, fancy. By the way, we call them Bowie, which is like burger. Sagar, do you get it? The name? Yeah, doesn't matter. Yeah, and then here we have the edge device, which is this AWS snow cone where everything is being connected to. And then finally there you see the video streaming, the live video streaming from the Turtlebots. But hey, Sagar, maybe you head over and share your screen and show how this thing has been operated.
Sure, André, thank you. So I'm going to share my screen. So hope everyone is able to see my screen. Okay, perfect. So hello everyone. So here I'm going to give an introduction about the UI first. So in the left part of the screen, you can see the UI which was developed by our team in order to check like some of the details about the robots which are present in our environment. So here you can see like the list of the robots, like the name of the robots which are present in the environment, and also the status of the robot. So here, like as we have like two use cases, one is like automated inspection mode and the listening mode, like which is the manual inspection mode. So currently like this robot is available in our network. So let's go inside that. And here you can see like when we go inside the robot, here we have a couple of buttons in order to control the robots. And the main button for our use case is the inspect, which will trigger the automated inspection based upon the pre-recorded path. So here I'm clicking on the inspect button now. So like in the right part of the screen, you can see the live video stream from the robot, and in some time like the bot will start to move, as you can see in André's window. So, and also I will start the recording of the video. So, and here in the left part of the left component, like you can see the control buttons using which you can using which the operator can control the bot and make the bot move around the environment and detect for the anomalies. So, and also like once the bot does his inspection, so here like the video will be recorded, and so So in some time, like the video recorded will be updated in the database, and also later, like the video will be taken from the database, and our AI model will perform some actions, and it will detect for some anomalies. So here I'm going to show the AI processed video, which is already saved in my local. So here you can see like our AI model is able to detect the objects which are like 3D printed objects in our environment, like barrel, and like you can also detect the spill over the barrel when the barrel is damaged and the nuclear waste inside the barrel is overflown. It will detect as the spill. Here above the bounding box, you can see that the spill is 0.98 or 0.99, which represents the confidence of the detected object. So yes, here again you can see like these barrels are clean, so it is only detected as the barrel. Yes. So, and one more main thing like I wanted to show was the this web application user interface using which all our containers which are running on the edge machine, like the back end, front end, and the computer vision part, like all these containers are run on the edge machine, and using this Portainer app, like we can just easily maintain these containers. So this was very handful, and yes, like that's all from the demo side.
Thanks,
So
Sagar. Yeah, but you get the idea. This is all about this whole processing is being done on the edge. So we have intelligent edge devices that really have like the main business logic, and then we process all these metadata, and this goes up to the cloud, and there we have all the benefits from the cloud. We build our applications, we can update our machine learning model, and so on. And this is, I hope you get now the idea how these things harmonize together, the edge together with the cloud. And it was really fun, implementing this over the summer, and we had really a lot of good time. But maybe Jan, maybe let's head over to you, and let's speak a little bit more about the architecture.
Yeah, sure. Thank you for your demo. So Falk already mentioned, yeah, we have the thought of a reference architecture. So how could what capabilities do we need to fulfill the upcoming edge requirements? So we use this showcase to really get some hands-on, yeah, and of course not have a use case where we could cover all potential ideas. Yeah, we talk about warehouse management, fleet management. We have kind of scratched at the surface, but some of these capabilities were really focused here. We think about the autonomy and the collision prevention, which the turtle bots are already capable of. The topic of human-machine interface, which we are deployed to the edge component, so that we are not depending on the cloud infrastructure there. But really important, our main focus was the edge. Yeah, how can we use the edge to extend our cloud network, and how can we integrate it in our cloud environment via edge deployment? So this is the thing Sagar just showed you. We have these Docker containers on our edge device, running on our edge device. But when you go to the next slide, Falk, we will talk about a little bit more of the technology stack. So what technology have we really used? And we really took leverage the services that AWS is providing. So looking here at AWS Greengrass, which we have, which we are using to deploy our code, our services, which we are storing and maintaining in the cloud to the edge device. So we are deploying the object detection, the web interface, the REST API, the database to the edge as an extension of our cloud using Greengrass. And further down the line, the data stream, the connectivity to the robot, we have a local 5G network in place in our center in Garching, but also using Wi-Fi as well, or as a second option. And on the device itself, so we have the turtlebot on the right-hand side, the icon, the burger bot, yeah, where we have the real sensors, actuators, cameras, but on top of it, we have already also some, which we call near edge or on-device edge, to host the robotic operation system, controller, and also the connectivity to the edge snow cone to enable the data upload, the video footage and which then are processed on our edge device, in this case, AWS Snowcone. So all of which was a very interesting case, and already the idea, okay, we have cloud, we have a robot, what's in between, how can we use it, where shall the compute power be positioned? And with our team, we had a great experience developing these, and looking forward to go to other cases and our ideas that we can apply on this architecture as well. Over to you, Falk.
Mr. Falk.
Great, yeah. So we would be open for some questions.
Okay. Hello, guys. It was wonderful. I didn't understand all the shortcuts. What is MQTT?
It's a typical IoT protocol used for device to infrastructure communication.
Ah, okay, okay. And ROT, that's two I was missing. ROT.
You mean ROS, maybe?
Yeah.
This is a robotic operation system.
Okay.
Open source a platform to enable robots.
It will be used by NASA to go to the moon, by the way. So we will be able to implement those kind of things.
Finally, and think about that. You have I think you have 2 or 3 windows per 24 hours to send the data. So you will have to be waiting and think about the rotations and everything. So don't forget to implement that.
With edge computing, no problem.
Okay, perfect. But you have to place the container on Mars first, right? And then somehow. Okay, I was thinking of one thing. What are the takeaways? What did you learn? Which technologies were useful out of the box? I saw a lot of AWS stuff, which is already there, and you could just plug into it, and that was working. And if somebody wanted to build something like this, what should you use out of the box, and what system you just don't touch the out of the box and program this yourself? Focus on this. Can you tell us about that?
Yeah, I think there were many lessons learned. I mean, right beside it was fun to do. So, I mean, we did this, of course, to have some lessons learned. Yeah, we want to showcase that we successfully can implement such key technologies like this Ross already mentioned, right? AI is always nice. IoT services from AWS. 5G is a big topic in, of course, robotics. And yeah, the whole idea is that we show we as the team, with IT/OT and Liquid Studio, we can build such cases. So this is the biggest lessons learned we had. And of course, we would like to demonstrate it to some possible new clients that are interested in those technologies, especially here in Garching in this industrial IoT center. We gained some inter-team project experience working together over the summer. That was really cool and nice. And of course, finally focusing on such edge technology was also very good to have such a demo case here around. And of course, not to forget this whole AI topic with the deep learning AI YOLO model and so on. Really have some more use case to show you around.
Right now, for me, it's really so much fun because right now, everybody, when you talk about AI and deep learning, it's okay, this deep learning and AI and this, and in 10 years, it's going to be killing us because it's going to be our faces in the database, and you make a wrong move in China and you're done. But now it's this AI, and 2030, you're I shouldn't have been joking about this.
But you know what? Our robots will take care of our nuclear waste disposal in 1 million years, drive around and upload it to the cloud. Yeah, let's hope so.
I was hoping for that, but you closed all the nuclear plants, Germans. Come on, come on. I love nuclear energy, and I know this is really the use cases. He can go there. We cannot go there. Everybody saw Chernobyl. I'm not going in. No, he's Turtlebot 1 is going in, not me. Mm-hmm. So I'm really, really happy that you are working at this. How much time do we have? 2 minutes, am I correct? 1 minute? Okay, so one more question. This is what I was trying to ask, so many different technologies. was it working together perfectly, or did you have to like do a lot of coding yourself? Or like, hey, this should be responding like this, and it isn't. Why? I don't know. It's undocumented. You write it, and Sagar was writing all the code. And in the end,
yeah, of course. When you really go to the new topics and the composition of so many technologies and also platforms. Yeah, I mean we have the first hands-on with this AWS Snow Cone device. We haven't seen it, used it before. This was a challenge. Then the robot operating system also needs to be embedded, and all the connectivity. But we are techies. Yeah, this is what we do. This is what we love. Yeah, to tackle these challenges and get insights and also knowledge out of it and talk about it. This is why we are here.
Okay, perfect. I'm so happy. Hopefully, there are some future customers of Accenture, and they now know that you can do that. So. Look forward for a 2-year stay in Chernobyl, cleaning the waste with your robots, and then you're going to be like, I didn't want this. I didn't want this. I wanted to go to Caribbeans and do something fun. But thank you, guys. This is really interesting technology and important technology. And you are so young. Come on, I want to die now. Okay, but keep on the great job. Thank you for joining us. It was a pleasure having you.
Pleasure to us. Thank you
for having us.
Thank you.
Bye. Have a good one.